The purpose of this video is to go over the definition of a periodic function along with talking about what trig functions are even and odd. At the end of the video, I will do an example problem just so people feel more comfortable about what we're doing with the unit circle. Again, we're evaluating. Remember that the y values, it's kind of a little confusing, I guess. The function itself is these trigonometric statements, like sine is a function, cosine is a function, tangent is a function, okay? And we're plugging an x value into it, and we're getting out a y value. Now that y value that we get out corresponds to the coordinates on the unit circle, okay? So there's kind of a couple things going on here. But what we're saying when we say a function is periodic is that on a set pattern, and it's different for different functions, but on a set pattern, the x values that we would plug in would give us the same y value. All trig functions are periodic. They don't have the same pattern. Like all six of them don't have the same pattern, but they are all periodic in some way. Okay, so let's look at what they're saying here with their definition. A function is periodic, that's what we're going to call it, if there is a positive real number c, such that when we add it to our original value, that y that we get out will be the same y value as the original value. For all, and this has to happen for all of the t's in the domain. The smallest number that makes that true for all of the t values is called the period of f. Okay, so it's a lot more simple than what it sounds. So the way I'm going to do this is kind of give you, I don't have a unit circle with me, so I'm going to try to do this real easy. So we know some of these we know all the axes. Since this is a unit circle, we have that one, we have this one, okay, so we're only looking at those. So what we're going to take a look at is, like, let's say we have cosine of 0. So then remember, cosine is our x values on the unit circle. So at the cosine of 0 is 1. And so then we can just say that right now. So then I'm saying that cosine is periodic. So somewhere along the line, as we move all the way around our unit circle, there's going to be a place somewhere where the cosine of that new number is also 1. Well, as we're going along, so we're looking for another x value that equals 1. So we're going along, it's not 1, it's not 1, it's not 1, it's not 1, right? Not 1, not 1, not 1. All of a sudden it's 1 again. So then what we can say is the cosine of 2 pi is also 1. And so then to write it the way the book has it there, they're saying, and before I go on, it's only going to be 1, it being cosine, it's only going to be 1 whenever we get back to the initial side, if you want to think of it that way. Okay, so it takes a full revolution for it to equal the same thing, and that's going to be true anywhere. And so then the definition is saying that there's got to be some value, and so like the way that they wrote it, like t would be 0. Okay, so if we're looking at this, our t here is going to be 0, and then our c value is going to be 2 pi. So then what we're saying is, to write it the same way, cosine of our t value is 0 plus 2 pi would give us the same value, in this case 1, as cosine of our t. So then since that happens, and it happens every 2 pi, we could keep going and going and going. So every 2 pi, we'd arrive back at the same spot, and that would give us the same x value on our unit circle. So then therefore, the period of cosine is 2 pi. Okay, so that's all they're saying there. All trig functions are periodic. Sine is also 2 pi. Okay, some of the other ones have different ones, but we'll worry about that later. Okay, so that's what's going on there. And then down here, they're saying even and odd trig functions, okay? And so we've talked about this even and odd idea in different functions before. The easiest one to remember is that x squared is even. So let's look at even, like, so if x squared must be even, there's two things that are going on here. Okay, the first one graphically is a little more obvious. Notice that it's reflected over the y-axis. So all even functions reflect over the x-axis. So what does that mean by what they're trying to say here? Right? Because they're saying cosine is an even one. All right, and then they say, well, if you plug in the negative value, you get the same y value as you put in as the positive value. Okay, so think about that on our x squared. If we plug in 2, we get 4. If we plug in negative 2, we get 4. So then x squared is an even function because negative 2 equals 4, and f of positive 2 equals 4. So then that makes it even, both of those situations, right? When you evaluate the opposite signs, you get the same y value. Okay, now, as a side note, I'm not sure why we're talking about this right now, because I think this is a lot more obvious when we look at a different way of looking at cosine, sines, and etc. Okay, so real quick on odd, so the famous odd function, or the easiest odd function, is x cubed. So there's two things going on again with odds. The first thing graphically is that it's reflected over the origin, and I think you can see that. So all odd functions are reflected over the origin. The other thing, similarly to what we were doing here, is that if we evaluate x cubed, right, this one's x cubed, if we evaluate that at, let's say, 2, we get 8. But if we evaluate it at negative 2, we get negative 8. And so then what they're saying here, and so what they're saying then is if we evaluate, so if this is our f of 2, so f of negative 2 is equivalent to the negative f of 2. So, right, negative 8 is equivalent to 8 times negative 1, right? Those are the same. So that's the definition of odd. So then all you need to worry about right now is keeping these straight. These are going to help us as we keep going. Okay, so the only even trig functions are cosine and secant. All the rest of them are odd. So that's the only part I didn't get to talk about yesterday. Again, I think this part, you should know the period thing. That should start making sense as you're going through some of these problems. But the even and odd thing, I think, saving it for future would be also nice. Okay, so just keep that in mind. So I wanted to do one example so that you hopefully feel a little bit better about this. I'm going to do, this is number 19 from your homework. I'm going to do all 6 instead of just the 3 like the homework says. So their angle is going to be 11 pi over 6. And so then the first thing is where the heck on the unit circle is that? So then, you have to go all the way around here, and we get all the way to 11 pi over 6. So you should be referencing the unit circle that we got together. So that coordinate there is radical 3 over 2, comma, negative 1/2. So the other thing that we need to know is what all of our definitions are. So all of our definitions are right here. And so again, the way you need to think about it is, if you take a sine of an angle, thinking of the unit circle, you're always taking the y value of that coordinate. Okay, cosine is always the x value of that coordinate. Tangent is the ratio of y over x, the coordinate, the y part of the coordinate divided by the x part of the coordinate. Okay, and etc. So you got to know these. Otherwise, knowing the unit circle won't do you any good. So then once we locate that, then we can do all of these. So sine of 11 pi over 6 is the y value here, negative 1/2. Cosine of 11 pi over 6 is the same as the x value right there, radical 3 over 2. Those are the most important ones, because if you know those, then tangent of 11 pi over 6 is simply the y value, negative 1/2, over the x value. Now you do want to simplify these, so we keep, change, flip situation, and you'll get better at doing this as you go. So we multiply those, we get negative 1 over radical 3. That's not standard. So then we multiply both top and bottom by radical 3. Remember, this is rationalizing. And so then the tangent is negative radical 3 over 3. And before I move on, I just want to say that, ideally, I think I said this yesterday, in a perfect world, I could ask you this question and you just go straight to, well, it's negative radical 3 over 3. But I'll be honest, I don't do it that way. I think of what my x and y values are and divide them out. Now, the more of this situation that you do, once you get here, you're basically correct. The more often you do this, the easier it'll get. Okay, so then really, if you know these two, then you can work with everything else. Okay, and so then everything else is really simple from there, because we still have all the information. And as long as you understand that cosecant is the reciprocal of sine, then you can go straight to cosecant 11 pi over 6 is negative 2. And then secant is the reciprocal of cosine. And so then we can say, well, that's 2 over radical 3. Okay, but we still want to rationalize that. So we're still going to multiply by radical 3, top and bottom. Again, you'll get quicker at this with the more experience you have. So then we're saying that the secant is 2 square root of 3 over 3. And finally, cotangent and this one I'm going to just jump, cotangent is the reciprocal of tangent. So then I'm going to just jump straight to that negative square root of 3, because I'm not going to use this, I'm going to use this. Okay, so again, maybe you go through the solution. So, maybe in the long run, like when you're not writing out all 6, if you're just asked for the cotangent, maybe what you could do is say, well, really that's radical 3 over 2 over negative 1/2. And then when you keep, change, and flip, right, you can get to negative radical 3. So probably, it's easy to come up with these last 3 if you have the first three sitting there looking at you. But if you don't, then if you're just asked, oh, hey, what's the cotangent of 11 pi over 6, you still want to go through this, okay, to get to negative radical 3. So I hope that helps. Keep working on them. Keep referencing the unit circle. Do those IXLs. It's all going to get you better at what's going on. But right now, you should be having that unit circle out, okay, and just going through it and making sure you're remembering it correctly.